Hello learners, here we are with another video on mass spectrometry. I am giving the tools and technique playlist in description where you can find more videos like this. Suggested books are here. Please read books for better understanding. So let's learn. In this video, these key points are discussed. Definition of mass spectrometry, concept behind this technique, how does it work, and application of the technique nowadays. A mass spectrometry is an analytical tool that determines the molecular mass by measuring the mass to charge ratio of ions in the gas phase. So this mass to charge ratio could be explained in a way. So this is the equation where the mass to charge ratio of a cation is equal to the mass of the cation divided by its charge. Since the charge of cation formed in the mass spectrometer is almost always +1, the mass to charge ratio of a cation is usually equal to the mass of the cation. Now we can find that the mass of the molecular ion is equal to the molecular weight of the compound. Thus, the mass to charge ratio of the molecular ion is equal to the molecular weight of the compound. It has three basic components: the ionization source, the mass analyzer, and the detector. The operation of the mass spectrometer involves the following steps. First is production of the sample in an ionized form in the gas phase. Next, the acceleration of the ions in an electric field, each ion emerging with a velocity proportional to its mass to charge ratio. Passage of the ions into a field-free region. And the last one is detection of the times of arrival of the ions, the time of light indicating the mass to charge ratio of the ions. A sample molecule studied by mass spectrometer must be converted to gas phase charged particle by the ionization process before they can be analyzed and detected. Several methods are used for converting the sample to ions. These processes are fundamentally different techniques, but they achieve essentially the same end result, which is the generation of gas phase ions via non-destructive vaporization and ionization. First, we are going to discuss about electron ionization. A beam of high energy electrons strike the molecules. The electrons molecule collision strikes an electron from the molecule, which create a cation. Then chemical ionization. The sample molecules are combined with an ionized reagent gas. When the sample molecules collide with the ionized reagent gas, some of the sample molecules are ionized by various mechanisms like proton transfer, electron transfer, and adduct formation. Now we are going to know about desorption ionization. So what is it? The sample to be analyzed is dissolved in a matrix and placed in the path of high energy beam of ions or high intensity photons. Now what? The laser desorption has modified by Franz Hillenkamp to a solid phase method, which is known as matrix assisted laser desorption ionization, shortly MALDI, which is most widely used technique for protein analysis. So in MALDI, analytes are placed in a light absorbing solid matrix. A matrix is used to protect the analytes from being destroyed by direct laser beam. Now, the solid matrix strongly absorbs the laser radiation and acts as a receptacle for energy deposition. With a short pulse of laser light, the analytes are ionized and then desorbed from the matrix into the vacuum system. Commonly used matrix materials are aromatic compounds that contain carboxylic acid functional groups. The aromatic ring of the matrix acts as a chromophore for the absorption of laser irradiation, leading to the desorption of matrix and analytes into the gas phase. Now we are introduced with electrospray ionization. John Fane introduced the electrospray ionization method, and during standard electrospray ionization, the sample is dissolved in a polar volatile solvent and pumped through a narrow stainless steel capillary. A high voltage of 3 or 4 kilovolt is applied to the tip of the capillary. As a consequence of this strong electric field, the sample emerging from the tip is dispersed into an aerosol of highly charged droplets. The charged droplets diminish in size by solvent evaporation, assisted by a flow of drying gas, and eventually charged sample ions free from solvent are released from the droplets. Once the sample has been ionized, the beam of ions is accelerated by an electric field and it passes into the mass analyzer, the region of the mass spectrometer where the ions are separated according to their mass to charge ratio. The most common mass analyzer is TOF, that is time of flight mass analyzer. The TOF mass analyzer measures ion flight time. It is based on the simple idea that velocities of two ions with the same kinetic energy will vary depending on the mass of ion. The lighter ion will have higher velocity because the ions have different velocities. The ion reach the detector at different times. The smaller ion reaches the detector first because of their greater velocity as compared to the larger ones. The analyzer is called TOF because the mass is determined from the ion's time of flight. The arrival time at the detector is dependent upon the mass, charge and kinetic energy of the ion. So this is the schematic representation of MALDI TOF mass spectrometer. Here you can see that the kinetic energy of ion accelerated through an electrical potential. So this is the equation where the E refers for kinetic energy, V for electrical potential, small v for velocity of an ion, Z for charge of an ion, and M for mass of an ion. So the velocity of the ion is the length of the flight path divided by the time. So it takes the ion to travel over distance. So we can write the equation replacing the value of small v in equation 1. So it gives us this. Mass spectrometry is used to measure the molecular mass of biomolecules, polypeptides and nucleic acid sequencing and to determine protein structure. Advancement of this technology opened new dimension in analysis of complex biological systems. It includes drug metabolism, lipid analysis, metabolomics, quantitative proteomics, direct analysis of intact proteins and imaging of proteins in tissues. Sequence information of a polypeptide is extracted using a technique called tandem MS. It can sequence not only 20 common amino acids but also known or unknown modified amino acids according to their mass. One MS method for peptide identification is called peptide mass fingerprinting. The unknown sample is digested with the proteolytic enzyme trypsin to produce fragments that are analyzed by MALDI MS. Post-translation modification processes like phosphorylation of hydroxyl groups in serine and tyrosine residue, etc. can easily be detected by MS. Small peptides and proteins may be sequenced by MS procedures and the peptide sample is ionized and fragmented. All the peptide bonds by collision-induced dissociation. ESI-MS and MALDI TOF are currently being used to investigate how proteins associate to form biologically active multi-subunit complexes. So we are done here. This is all about today's video. Please share your suggestions, queries, and subscribe for more videos like this. I'll be back soon with another video. Till then, stay with Paperpenbiology. Thank you for your patience.